today's day will hinder you for many years to come. Just because the concepts today are easy, but they can be confusing. As is math. Math is not hard, it's just confusing. Negative numbers. And I suppose it would do us well. Let us just draw ourselves a nice little number line. And we've discussed this before. We're pretty familiar with the positive numbers. They're pretty easy to work with. We do this all the time. But negative numbers, which are the numbers on the back side of the number line that go on forever, can be a little bit confusing at times. God bless you. Okay. Everything going to the right of 0 we call the positive numbers. And everything going to the left side of the unfair number line are the negative numbers. And it's important to know, number one, that on a number line, any number to the right of a number, hashtag, is bigger than it. Bigger than that number, hashtag. I'll give you a chance to write that, and then we'll just briefly discuss what that means. It makes a lot more sense when we deal just with positive numbers, but when we get to negative numbers, maybe it can be a small bit confusion there. That little statement just means this. If I looked at the number 2, ladies and gentlemen, let's just say I'm looking at this number 2. Any number that's to the right of it on the number line is going to be bigger than it. For example, 3 is bigger than 2, 4 is bigger than 2, 5 is bigger than 2, whatever is over here is bigger than the number 2. So with that standing to reason, if I'm looking at negative 5, the same thing is true with negative 5. Any number to its right is bigger than it. So if I am comparing negative 5 to negative 1, what is actually bigger? The negative 1. Because it is to the right of it. And something that I like to, think about negative numbers. It maybe helps if you think about negative numbers is like money you owe somebody. Okay? If you owe somebody $5 and you owe them $1, it's better for you to owe them $1. Okay? You actually have more money if you only owe them $1. Because for the money you get, you're going to have to pass them on. Like your parents, they go buy a house. Okay? Is it better for your parents to owe no dollars on their house, do they have more money, or is it better for them to owe $150,000, which is negative money? What is actually bigger and better for them? Eddie? $0. 0 is bigger than any negative number because it's better for you not to have any money than to be in debt to somebody and owe them a lot of money. In fact, probably if you asked your parents, if they'd like to have no money or owe people thousands of dollars, they'd probably tell you, yeah, I'll take the no money because that's just the way it is. All right. Then, ladies and gentlemen, here is the next, let's write this down too. Something else to remember, hopefully, we probably should put it on a different piece of paper, but we'll put it right here. The word opposites. The word opposite just means if it's negative, it means it's positive. When it's positive, it's negative. I can't really explain it, but let's do an example. The opposite of 7 is negative 7. When you talk about opposites of numbers, you just make it their opposite. If it's negative, it's positive. If it's positive, negative. For a same thing is the opposite of negative 15 is positive 15. The opposite of negative 15 is positive 15. So it just changes it from negative to positive, positive, negative. And then, a little point to ponder. Point to ponder. P, P, P. What do you get if you add a number and its opposite? What do I get if I add a number and its opposite? If I take a 15 and add a negative 15 to it, or if I take a 7 and I owe a negative 7 to it, or if you owe somebody $7 and you get and have $7, what do you get if you put those together, Frankie?
0.
Yes, you get 0. You get 0. Big fat goose eggish. And now the last thing that's going to, this is probably the single most intellectually stimulating thing you will learn this week.
Listening.
Right? Check this out, Andrew. Are you with me? You and Colton having a moment together, or what's going on? All right. Take this out. Let's look at some subtraction here. Okay, because this is where kind of negative numbers come into play. Most of you know that 7 minus 5 equals what? 2. Now, it's logical in subtraction generally up until your 6th grade year here. You always take the smaller number and subtract it from the bigger number. Okay, the bigger number is always on this side. But what happens if their roles are reversed? What if I have 5 and I subtract 7 from it? Now that's a little goofy because if you have 5 apples and you try to take 7 away, it's pretty tough to do because you run out of apples after 5. Okay? But the beautiful thing of this is this. 7 minus 5 and 5 minus 7 both give you 2. Except when you take the bigger one away from the smaller one, you get a negative 2. To which you may say, well, so what? Yeah, well, it's not so bad when you look at small things like this, but if I gave you this, if I said, what is 62 minus 300? 62 minus 300. And this is a mathematical thing I like that Kelly brought home when I said think of an easier problem. Okay? If you use the same philosophy to do this problem as I did to this problem, when I did 5 minus 7, what did I actually do? I found the difference between 7 and 5. I actually subtracted 7 minus 5. That's where I got my 2 from, which means to do this problem, you are still going to take 300 and subtract 67 from it, which will give you 62, which will give you 238, except your answer is not 238. The digits are right. It's just that you're taking the bigger one away from the smaller one, so your answer has to be negative 238. You got that?
Yeah.
Same example. If I said, what is 150 minus 2,200? Okay. First things first, it should automatically set off in your head, I can't take a bigger number away from a smaller number, so I know my answer is going to be negative. But to figure out what the negative is, what am I going to really have to do? Andrew?
Subtract.
Yeah, you're going to have to put the bigger one on top because you can't subtract any other way. Subtract 150 from 2,200, you get what? 2,050. But that needs to be negative 2,050. And there are still 7th and 8th graders who don't quite catch on to this. What is 20 minus 30? You're taking a bigger one away from a smaller one, Julia, you get?
-10.
Negative 10. What is 70 minus 40? Sam?
Negative 30.
It is not negative 30. And there's something else you have to teach yourself, that just because we learn something new doesn't mean the old rules don't still apply. 70 minus 40 is still 30. 40 minus 70, Sam, is negative 30. Thank you very much. That's something you just got to get used to. Sometimes you learn something new and then you think it's always the case and you forget that, you know, that's not always, it's only something. How about 15 minus 18? 15 minus 18 is, Nathan?
Negative
3.
3.
25 minus 15 is, Jacob?
Negative 10.
It is not negative 10. Jacob, 15 minus 25 is negative 10, but 25 minus 15 is 10. And that you have to, people, you have to recognize if the big number comes first, it's going to be positive. If the big number comes second, then it's going to be negative. Don't fall into the Sam and Jacob trap. What is 75 minus 25? Jordan? 50. What is 25 minus 75? Victoria?
Negative 50.
Negative 50. All right. Get that into your memory banks. Don't let that whole thing kind of confuse you and fool you. And then, by the way, if you want to, let's just talk some mathematical terms here. Just because if you say this to your parents, they won't understand. The negative and positive numbers, when we put them together, like we were talking about today, this group of numbers we call the integers. And I think we talked about this before. Integers should make you happy because integers are only the positive and the negative whole numbers. You don't have fractions and you don't have decimals when you're talking about integers. Okay? So anything we talked about today where you don't see any decimals, any fractions, they're whole numbers, they're both the positive and the negatives, those are integers. So when the book tells you you're using integers, usually you are, unless you're dealing with fractions or decimals, but I don't think we've had any fractions or decimals yet, have we?